Okay. All right. So we're gonna keep working in this section 4.4. So there's a question in the homework that has these instructions that's been getting people really confused. So I want us to do this one together. It's very similar to one in the homework. And then we'll go through it. So what we're going to do on this one first is we are asked to prove or to show that this has no rational roots. So our first thing we're going to do is make our list of all possible rational roots. Our P over Q situation. I was checking. Is that precious over there? Yeah. Okay, cool. Judging from the back of the head, I couldn't tell if it was just as precious. All this needs back up.
No, but the big test is November 8th. Well, your birthday's next week. You have to tell what it's the day after your birthday. So
What is that?
9 days, I think. Next week. The test this week.
Oh, we have another quiz this week.
Yes, on Friday.
Oh,
It's on Friday. I am going to put together another review for it. I had a lot of people say that was really helpful.
Yes, it was.
So I'm going to put together another review. I'll get those and get them printed out for you guys. Hopefully for tomorrow, I'll have them for you.
That was a great idea. I love it.
That was great. I'll try. I'm going to try today.
So I will do my best to get that printed out today. I'm tired of this thing running out, or almost running out in this class. So on this problem, we're going to start with our list of all possible rational roots. So that's what we did yesterday, where we had our factors of P and our factors of Q, where we're storing factors of our constant and factors of our leading coefficient. So, what is our constant? What is the P? 7. What is our leading coefficient? The Q. One. Yep. So, yep, we're doing the P and Q thing. So P is our constant. So in this case, it's 7. And our Q is the leading coefficient. So in this case, it's 1. So we're going to do our all possibles for our all possible rationals. And those are our plus or minus and the ratio of the factors of each of these. I've got to put this behind a chair or I'm going to trip over it and I'm going to fall. Just because that is who I am as a person. All right, so what are our factors of 7? 1 and 7. And what are our factors of Q?
1.
Just 1. So we're going to have the ratio between P, the factors of P and the factors of Q. So what are all of our possible roots?
Positive and negative 1 and positive and negative 7.
Yep, plus and minus 1 and plus and minus 7. because the factors of 7 are 1 and 7. So it's P over Q. 1 over 1 gives us 1. 7 over 1 gives us 7. So when they say, show us that this has no rational roots, what they want us to do is to make this list and then substitute them in to see if any of them are roots. Because if it's a root, what's it going to equal?
0.
0. So we're going to see, what does f of 1 equal? What does f of minus 1 equal? What does f of 7 equal? And what does f of negative 7 equal? That's how we show this. So what we're going to do is we're going to substitute those in. And we are lucky, lucky ducks that get to use calculators too. Okay. That's probably why this was in the donation room. Is this? Oh, there we go. That one actually has some resistance to it. These plugs are very loose. So we're going to substitute these in and find these values. Type them in the calculator. I mean, some of them we don't need to. 1 we could definitely do by hand. 1 to the 4th is 1. Minus 9 times 1 plus 7. So 1 minus 9 plus 7. What is 1 minus 9 plus 7?
2. I mean, never mind.
Negative 1.
Sorry, I was trying to do this math.
That's okay. We missed the first step. So 1 minus 9 plus 7 gives us negative 1. So this one is not a root. What value do we get for f of negative 1? We should get 17. So that one is also not a root. We substituted in, so when in doubt, we're going to have our, make sure we include the parentheses on these things. So our negative 1 to the 4th. Ooh, I don't have the equation in front of me. So minus 9 times negative 1. Plus 7, right? Type it in. You get 17. Do 7 and negative 7. What values do we get?
Is this supposed to be a really big number?
It may be a big number. Yeah.
That's what I was saying.
Yeah, I was right.
345? Yep, that sounds right. What do we get for negative 7? 471. If you wound up with a negative number, you forgot the parentheses around your negative 7. And the calculators are notoriously terrible with order of operations, especially with negative numbers and exponents. So if you type it in as negative 7 to the 4th, the calculator sees this as negative 1 times 7 to the 4th. And so that's what the calculator does. So if you wound up with a negative number on negative 7, you'd made a mistake because you need to put the parentheses on it. Then it will take negative 7 to the 4th. Otherwise, you're doing the opposite of 7 to the 4th. So be super careful with that. That is a super common mistake we make, is we write it like this in the calculator, and the calculator is wrong. So that is one of the downsides of getting calculators back, is then we get calculator errors.
Because we know how to fix them.
As long as we fix them.
Right.
That would be the thing.
So none
Because
of
we
them reached out.
So none of these are roots at all. Which is exactly what we were asked to show.
Oh.
Well,
But if it had, the thing is,
so
it
are
does
they
show
all
the different
irrational?
Yeah.
Oh.
It will have imaginary roots.
Okay.
And in fact, I believe this one only has complex roots.
You didn't?
Wow. I took this out of the book. It's one right next to one of the ones that's assigned as a homework question. And so I wanted us to see it because it has these instructions and everyone's like, I don't even know where to start. So I wanted us to do one like it. So since none of our P over Q, that's a Q. I'm just going to rewrite that Q. Options are roots, There are none. No rational roots. Well, you're just going to show the values of it. Like, you don't have to write the whole sentence. I'm just putting it on there so that we know what this is and why it's saying it, just in case we look back at notes later to see what that was and why did we stop and what the heck. So, trying to make things clear even if you're not actually listening to me talk. Okay, so on the one that says, show that your function has no rational roots, make your list of all possibles, plug them in, show me the values. Don't just say they're not. On a lot of these questions, it's more about the work than the answer, because I'm starting to post things like, answer keys or the teacher version of the questions that has the final answer at the bottom. So make sure you're showing the work. The work is the more important part anyway. Because these problems that we're doing in this section in particular get real long. These can be very long problems. Because they are. Because DC Precal. Just one of those things. It's one of those things. Sometimes our questions are long. And we're going to do a couple of the find all possible solutions for our polynomials. And I'm just saying this to you guys at the beginning. I told my last class at the end. I'm going to do different questions with you than I did with my previous class. I'm recording both. So if you want to watch more examples, I have the third period class that is in process of uploading right now, and I'm going to record this one and upload it too. So we'll have 2 sets of problems that you can look at. That first question is the same for both of y'all, because I wanted us to practice it. But the rest of them are going to be different questions than I did in third period. So if you want to see more options, there's videos that are going to be up, and the PDF copy of the notes will have all of them in the same one. Okay, so just share it. Because our first one that we're going to do, I'm going to make sure I get to the right one because I had to reorder all my slides. Boop, is this one. We are asked to find all solutions of this equation. And it's always a good idea to kind of like peek in and see, does this thing factor? Do I have to go the hard way through this? And unfortunately, yeah, we do gotta go the hard way through it. But it's always a good idea to stop and check, because sometimes we are nice or we miss something. And we accidentally gave you something factored. Not often, but it happens. Okay, so what we're gonna do here to find all of our solutions is we're gonna start with our list of all possibles. So that means we're going to find our P, we're going to find our Q, and we're going to find our ratios to make our list of all possible solutions. So what is our P? Negative 12. On the P and the Q, the signs don't super matter because we do plus and minus with everything anyway. So if you put negative 12, that's totally fine. You can also just put 12. Like, it doesn't really matter. What is our Q? 1. We love a Q of 1. That makes things much easier. So our all possibles are going to be our factors of 12 over our factors of 1. There is an L in the word possible. Possibly. So we're going to take our positive and negative plus or minus factors of 12 over factors of 1. Well, 1's only factor is 1. So it's really just our list of possible factors of 12. So what are the factors of 12?
1, 2, 3, 4, 6, 12.
Uh-huh. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Not for any particular reason, just keeping them to the side so they're visually not all across the page. So it'd be really nice if we could kind of narrow that list of 12 options down a bit. So let's see if our Descartes will help us kind of rule something out. So our Descartes rule of signs, I'm going to do that up here in the corner. How many positive roots are we going to have? It's like change. How many sign changes in this original equation? One. So we're going to have one positive root because there's one sign change here. To do our negative roots, that's when we do our f of minus x and we substitute that in. Odd degree powers will change sign, even degrees will not. So if we have minus x cubed plus 7x squared minus 4x minus 12, how many sign changes do we have in the negative version? 2. So how many negative roots are we going to have? 2 or 0.
Wait, so pairs only a negative?
The only ones that come in pairs are imaginaries. Imaginaries always come in pairs. That's why we count down by 2s.
Oh, wait, no. Then why do we have to do 2 or 0?
Because if I even have one negative root, it means I'm going to have 2 because I'm going to have a total of 3 roots. And I know I have one positive root, but I might not have any negative roots. Maybe I have one positive root and 2 imaginaries. So it always counts down by 2s. What's up?
Why is your 12 negative?
If we substitute in minus x, this guy isn't going to change because it doesn't have an x to it. So its sign isn't going to change. It's only the ones that are odd degrees that actually change sign.
Oh.
Okay, substituting in our minus x right here. This is only for the Descartes part. And all that does is help us kind of choose which ones to kind of guess and check on. You don't have to do this, but if we do something like this and we wind up with no negative real roots and we start and only do negative numbers, we might get real frustrated if we do like a big list and I have no negative real roots. Especially if I wind up in something that can't have them. If I have a 0 in one of my rows, I know for sure I won't have negative or I won't have positives. And that's all we start substituting in. It's going to be really frustrating.
Wait, so we only change odd?
Yes.
Why is that?
Because if I have, like, say, for example, if it was negative 1 as a value. Negative 1 cubed would be negative 1. Negative 1 squared would be positive. So the sign doesn't change because the even degreed exponents, the negative signs cancel out. Okay? So if you want to go back and practice that more, the day that we went through Descartes, which was, I want to say Monday, would be when we did that. I think we did, yeah. No, I think we did that on Thursday. That was right before the quiz. Yes. So it would have been Thursday. So if you want to go back and look more at the Descartes stuff, that was Thursday of last week.
Okay.
Okay? So, what's up?
I thought it was called Des Kids.
It's French. Descartes, it's the dude's name.
I think pronounce the S.
I've seen too much music, I'm sorry.
I have only ever heard it as Descartes. But as far as pronunciation goes, I don't care. However you want to say it, however it works in your brain, Descartes was just like one of those mathematicians back in the day who was making stuff up when nobody had made anything up about math, so he's got a lot of things assigned to his name.
What's his name? The dude who made the mag?
Pythagoras.
Yeah. Oh, that's his name, Pythagoras.
His name is Pythagoras.
Oh.
He was from ancient Greek. That's why it's the Pythagorean theorem. He was one of the first math teachers like ever, and so the people who followed him were Pythagoreans.
Oh.
Because he was like
They're fans.
super awesome math guy, and they're like, we're following Pythagoras. We're Pythagoreans. So that's what that is. He had a fandom. He was another one of those guys that has a whole lot of stuff attributed to his name because
First idol.
he was like OG math, proving everything. He was doing math stuff before they were like really everybody agreeing on what numbers were.
Oh, okay.
A lot of his stuff he does with just lines and circles and things being congruent versus not being congruent. So you don't need numbers for it. Okay, so what we're going to do to find our solutions here is we're going to kind of guess and check. and substitute in values trying to find roots.
For all of these?
We're going to go in sequence, and when we find one, we'll be able to make our lives easier. So, but we don't really have a way to narrow it down at this point aside from guess. So, well, how? What would you do?
I don't know.
We need more information in order to be able to solve, which means I need to know what something that works is. So, what value do you want to substitute in first? Descartes just helps us decide. I could have 2 negative values, or I might have 0 negative values. So if I have no negative values and all I substitute in is -1, -2, -3, -4, -6, -12, I might wind up really frustrated. I know for sure I have 1 positive root. So we might go with that. But the reason we check is because sometimes when we do Descartes, we wind up with no. There's no sign changes in either the positive or the negative, so I'm not going to have any negatives or whichever roots. So it helps us narrow our options. We're just going to kind of guess and check through until we find something that works. Okay? Luckily, y'all get to use calculators.
Oh my gosh.
Remember, like last year they didn't. What's that?
So like if you substitute one number and you get a positive, so then you don't substitute any other ones.
It's if we substitute in and we get a positive root. So it's not that we get a positive value. It's that like if I substitute in +3, +3 winds up being a root. I know I don't have any other positive roots. So we can use that to help kind of narrow things down. Okay, so we're going to pick pieces and substitute them in. So what numbers do you guys want to do? You can do 1. Somebody do it. Somebody else do another one.
0.
F of 2. What did we get on 2?
Oh, I didn't do it yet.
So do it. Substitute them into the equation.
F of 1 equals 0.
F of 1 equals 0. Oh my goodness, look at that, lucky ducks. We wound up at a root. If we get a 0, that means this guy is a root.
So none of the other positive ones are the root, right?
We only have 1 positive root. So even just from that, I know we're not going to have any more positives. But we can also divide that guy out and make our lives a little bit easier because we don't have to do everything with our cube. We don't just have to substitute in absolutely every value. We know that 1 is a root, so let's divide it out and see what's left. So I'm going to take in the fact that 1 is a root,
Smart.
and I'm going to divide it out. What are my coefficients as I'm putting together my synthetic division?
1.
1, 7,
4,
4,
negative 12.
-12. So we're going to divide this out. First time drops. 1 times 1 is 1, plus 7 is 8, times 1 is 8, plus 4 is 12, times 1 is 12, and we wind up with a remainder of 0. So again, proof positive that we have a remainder here of 0. This would be how we would do all of the substitutions before we had calculators allowed in here. We did everything synthetic division style.
Okay,
So what does this give us as a leftover polynomial?
X squared plus 8x.
Yeah, 1x squared plus 8x plus 12. It gives us our 1 degree smaller. So this was a cube, so this is now a squared.
right.
So then my next question is does this guy factor? With what? So pair of numbers that multiplies to be 12 and adds to be 8, 6 and 2. So what are our factors?
X plus 6, X plus 6, X plus 2 plus 2. And negative 6 and negative.
Yes.
So what are all of our roots? Because the most common thing people will say is my roots are -6 and -2 and I'm done. How many roots do we need?
3.
What's my other root? 1. That positive one that we found over here. We can't forget about that guy. Okay? questions on this one?
So there's another one.
Oh, we're doing another one.
Oh, okay.
Absolutely. We've got 20 minutes. We are definitely doing another one.
This class feels forever.
It is 10:17. We have until 10:36.
Oh.
We have plenty of time. So, but questions on this one before I change the page?
What? 30?
Oh, be thankful the last class had one that was 120.
What? No. How many
That-
P's were there?
It was a fourth degree though, so y'all are a fifth degree, but it's a smaller number.
Okay.
So they had a fourth degree, but their P was 120.
I don't like that.
I don't appreciate at all.
We'll be okay. So write down our polynomial. And then our first job is to find our P and our Q. Our P is 30. What's up? Q is our leading coefficient, so it would be what's in front of our biggest degree term. So in this case, it's a 1, which we love because then we don't have fractions. I was going to say we can't. We did. I would say we started making lists of that yesterday. We did something like that, but let me see if there's any on the homework that are like that. What's up? There's only a couple in the homework that have A values like that, but all that does is change your starting list. All right, so then we're going to find our all possibles. What's that?
Do they all have Q's of 1 homework?
No.
Okay.
I think there's 2 that they're not humongous lists. So our all possibles are going to be what options?
For P?
It's the ratio between our factors of P and factors of Q.
Minus 1 plus minus 2 plus minus 3 plus minus 5 plus minus 6 plus minus 10 plus minus 15 plus 30.
I think we have to stay on the minus.
All right. 3. I was like, you jumped ahead of me. So 5, 6,
I'm losing my breath.
10, 15, 30. There we go. Whew. And you don't have to write them in smallest to biggest order. If it works better for your brain to do 1 and 30, 2 and 15, 3 and 10, 6 and 5, that is 100% valid. That is a lot of the times how I write it in my answer keys because that's the way my brain works. But whatever works for your brain, y'all were getting them in order. More power to you. So let's see if our Descartes helps us out at all. Figure out what kind of roots we're going to have. So how many sign changes do we have here in our original function? How many positive roots are we going to have? 4 or 2 or 0.
Wait, so only if it's even do we do the or thing?
No, if it's bigger than 2. So if it could be 3 or 1. It could be 5 or 3 or 1. It could be 6 or 4 or 2 or 0. We just count down by 2s. Because imaginary roots always come in pairs. Every single time. Imaginary roots only come in pairs. So let's see if our negative helps us at all. So if we have a minus x to the 5th plus 18x cubed plus 30x squared plus 19x plus 30. This is our f of minus x, substituting that in. So how many negative real roots are we going to have? 1. We only have 1 sign change here. So we might have 4 positive roots, and if we want to go that way, we can absolutely take that gamble. We might wind up with 0s. We just have to be prepared for that. What's up? The 4 came from how many sign changes we have in this original function. So it was positive, switches to negative, switches to positive, switches to negative, switches to positive. So we had 4 sign changes. That's where that came from. So we know we're going to have a total of how many roots? 5. Some may be positive, some may be negative, some may be imaginary. We can use whichever values we want. We just have that up there to help us kind of see our options. We know if we find one positive root, we're going to find at least one more because they're only coming in 4 or 2 or 0. If I find a negative root, that's probably going to be my only one because I only have one negative root available. So you can use whichever options you want. That's just a kind of another tool to help narrow down our choices. So substitute in values so that we can kind of figure out what's going on here. What do you want to start with? So start with, I've heard somebody say 1, do -1 too. Totally fine. What are the values that we get? I'm holding. I was just writing them down.
It's not negative. Okay, it's not 1. It's not 1. It's 2.
So I was going to say put in our values as needed. So 1 is definitely not it. -1's not it. I was going to say, I'm going to get the values just because I don't have them. So this one we should get 24 on, and on the -1. We only need 1 to start with.
For positive?
For anything. I need 1 root. Then we can divide.
Wait, can we divide it twice then? Because we found 2.
So we'll work with that. I was like, there's 1 point for us. Let's start with 1.
Please.
What do we want to use? What did you guys do next? 2, which had a value of 0. So I know that the 1s weren't working. So I know those guys don't count. And 2 is a positive root. So what we can do is I can divide out that 2 to get something that's left over, right? So let's do that. We're going to take that factor of 2, because we know this guy's a root, and we're going to divide it out of our polynomial. What are our coefficients going across our synthetic division here?
1, -0, No, are you serious?
We've got x to the 4th. We can't skip it. So our x to the 5th, we had 1. I have no x to the 4th, so there's a 0 in there. -18, 30, -19, 30. If you don't have that 0, something's going to go wrong. You would have gone up with a remainder, and then we would have had a problem. So now do your synthetic. You have 1, 2, 2, 4, -14, -28, 2, -4. Oof. Oh, +4. I'm like, what? There we go. -15, -30, and our remainder of 0. Okay, so that leaves me with a polynomial of, instead of x to the 5th, now we're at an x to the 4th. So this is x to the 4th plus 2x cubed minus 14x squared plus 2x minus 15. And it doesn't feel like it helped us all that much. However, what is the p for this polynomial? 15.
Oh, you want to do that again?
No. We're not going to start from scratch on there. Because our roots have to be factors of p, right? Is there anything on our list of all possible factors that is not a factor of 15?
2. All the even numbers.
Yeah. So we have a new p-value. So anything that's in my list of all possibles that is not also a factor of 15, not going to happen. So 2 is not a factor of 15. 3 is a factor of 15. So is 5. 6 is not. 10 is not. 30 is not. So we've gone down from 1, 2, 3, 4, or gone down to 3 options from the 7 that we had left. So we'd eliminate out a bunch of things just by looking at that remainder. So must be a factor. So cross out, just writing it down, non-factors. And then we can do the same thing. And you can substitute into either polynomial, either into your x to the 5th or into your x to the 4th, working with the next pieces that we have, trying to find another one that works. But now instead of having 7 plus or minus, so 14 options, now I'm down to 6 options, which is a lot more manageable. So what would our next root that we bump into be? You can do 3. Is 3 a root?
Yeah.
Yeah, f of 3 is 0. So we have another root at 3.
So do we take it out again?
So we can actually take it out of this guy. So we're going to divide 3 out of our remainder function. What's up?
So that f of 3,
Mhm.
you get it out of the original?
You can get it out of either one.
It doesn't matter if it's
It should be a 0 for either one. Yes. Because all this is, if I took this and multiplied it by x minus 2, I'll get this guy back. So this is a factor of this as well. It's just not a pretty factor and it doesn't help us at all. But this is a factor of that if I divide it by x. So now we can divide that 3 out of our 4th function, our quartic. So I'm going to take all my coefficients from that, my 1, 2, minus 14, 2, minus 50. These can be long. And we're dividing out our 3. Because we found that 3 was a root when we plugged it into either one of our polynomials. So when we divide that out, we're going to have our 1 and our 3. Add those together. 5, 15, 1, 3, 5, 15. And so we again see that we had this remainder of 0, so it worked out right. It lets us double check it. What is the degree on this remainder down here?
3.
Yeah, so this is going to be x cubed plus 5x squared plus x plus 5.
Wait, do we have to keep going until we can factor?
We need all our roots.
I thought we already have 2 though.
We have 2 roots.
So that's it, right? Because it has to be in pairs.
We need to find how many roots is this polynomial going to have? 5.
And we only have 2.
We only have 2. I know 2 and I know 3. So this guy down here,
It only has 25. But that would be right.
I was like, you can. Yeah, P of 5. But I was going to say, at this point, I also want you to look. I'm going to give us a little bit more space down here, and I'm going to change the view.
15 doesn't work.
Can we factor that?
By grouping?
Oh. I forgot about that.
You don't have to go back to your all possibles. Check and see if it'll factor. Once we get down into the cubes, sometimes we can. Almost every time when we get down to the squares, we can. So if we factor this by grouping, we're going to have x squared coming out of the front, leaving us with x plus 5, plus 1 times our x plus 5. So our factored form here, we have our x plus 5 and x squared plus 1. So what is our root for this piece?
-5.
Negative 5. What is our roots for this piece?
Is that what is I, right?
What's minus negative?
So when in doubt, set it equal to 0. X squared plus 1 equals 0.
Wait, do we have to put the 1 there?
What's the square root of negative 1?
This plus 1? Or yes. This guy has to be there.
Like, why did you pull that out?
Because there is still a common factor between them of 1. If I didn't have this and I just had x squared times x plus 5, it would not multiply back out to be this guy. So you have to have that 1. What is the square root of negative 1?
I don't remember.
Yes, you do. I.
Is plus and minus I?
Yes, indeed it is, because it always comes in pairs. Plus or minus I. So what are our roots? All of our roots.
Plus or minus 2.
Plus or minus I. That gives us 2 roots. And negative 5. That's a third root.
2 and 3.
2 and 3. And we still have our 2 positive roots, our 1 negative root, and we have 2 imaginary roots. Okay, so these problems can be really long, and sometimes in the middle we can help eliminate out pieces. Always check and see if there's something we can factor, because factoring is usually faster. What's up?
Why can that be imaginary?
Because we can have imaginary roots. Like, that's totally fine. What I have is I have 2 positive roots and 1 negative root, which means I get 2 imaginary roots to my total of 5. I have to have a total of the degree. So we should always have the same number as I have as my degree in my polynomial.
And then I start.
Okay?
Why do you always ask for the same thing?
So, I'm going to put the homework questions up. I will get the video of this one uploaded. The period 3 video should be uploaded. So if you want to watch more examples of this, I did 2 different questions in the period 3 video. So there are 4 different find all possible roots posted on the YouTube channel. Okay?